Life originated on Earth via montmorillonite clay, which we have pictured here. Montmorillonite clay is believed to be a catalyst of organic reactions, like the formation of RNA nucleotides, which we have pictured here. RNA is believed to be the first genetic unit of life. This implies that montmorillonite may have catalyzed some of the reactions on primitive Earth. Montmorillonite is formed from volcanic ash and is believed to have been present on primitive Earth. An experiment was conducted to measure the kinetics of montmorillonite. Kinetics showed that montmorillonite speeds up the RNA nucleotide formation 100 to 1,000 times more than that of the hydrolysis of the middlosol activating group, which acts as a leaving group in the formation of RNA nucleotide. The results of this signifies that montmorillonite could have been a catalyst of the formation of RNA, the first genetic unit of life.
It is often believed that DNA was always the storage site for genetic information. The RNA world hypothesis states that before DNA, RNA was the main source of genetic information. Evidence that supports this theory is RNA's ability to both catalyze reactions and store genetic information. Another piece of evidence that supports this theory is the fact that ribosome is a ribozyme, which means on primitive Earth, RNA was catalyzing chemical reactions before proteins were. More evidence that shows that RNA came first is the fact that deoxyribose sugars are made from ribose sugars in the cell. Although DNA came to the scene later, it became the main source of genetic information due to the fact that it was more stable.
DNA has been found to be more stable in holding genetic material. It has been strongly hypothesized that LUCA was the last universal common ancestor. LUCA most likely was a single-celled organism that lived between 3 and 4 billion years ago. Specialists believe that the two earliest remains were bacteria and archaea, and that eukarya emerged later on. Dr. Martin and his colleagues did an experiment and saw that the 355 genes met the criteria for having connections towards LUCA. Genes adapt to their environment, which made a significant finding that the 355 genes pointed precisely to an organism that met the conditions to live in a deep-sea vent. LUCA may have been dependent on hydrogen and metal favors in a deep-sea vent environment for the origin of life. As we progress from simple to more complex organisms based on structural components, it is believed that LUCA was the last universal common ancestor.
LUCA started in different areas, even in areas like a deep-sea vent. So that means if DNA is important, where would this have happened? Maybe in something like a hydrothermal deep-sea vent. Hydrothermal vents are thought to have a majority in the source of gases and dissolved elements to the modern ocean. The deep-sea vent theory suggests that life may have begun as submarine hydrothermal vents spewing key hydrogen-rich molecules. Even now, these vents, rich in chemical and thermal energy, sustain vibrant ecosystems. At the time of life's origin, the early oceans was acidic and filled with positively charged protons, while the deep-sea vents spewed out a bitter alkaline fluid which is rich in negatively charged hydroxide ions, kind of like a battery in a way. That battery then powered the chemical transformation of carbon dioxide and hydrogen into simple carbon-based molecules such as amino acid or proteins. Eventually, that gradient drove the creation of cellular membranes, complicated proteins, and ribonucleic acid, a molecule similar to DNA.